All right, we'll start now, chapter 2, which is network models. And as always, the comments are open. So if I say something wrong, you can mention the minute and the second and correct anything you think that I said wrong. Or maybe if you have more information to, you want to elaborate more or to enrich the content, you can also do so by commenting in the comments, so that the other can benefit from your knowledge. And of course, these slides are the credits all reserved for KFUPM, so the slides won't be shared. All right, let's start. The objectives is to describe layered tasks, introduce the OSI model, introduce the TCP/IP protocol suite. All right. Layer task. Here we are just giving an example to illustrate that what do we mean by layer tasks. We use the concept of layers when communicating in our daily life. An example of that, let us consider two friends who wants to communicate, Maria and Anne. What if the friend still wants to communicate, but one of them has moved to a different city? Here we will show the process. From the sender to the receiver. It's just like explaining the layer concepts. So if you want to read it, it's clear, but it just like goes from here to here. Open System Interconnection OSI model. In 1984, the Open System Interconnection OSI reference model was approved as an international standard for communication architecture developed by the International Organization for Standardization. ISO is an organization, OSI is the standard model. So just reversing the letters. So be careful of that. Has 7 layers, of course, and we will know later that TCP has 5 layers. It covers all aspects of network communication. It's the theoretical system delivered too late uh, because it's not dominated, because TCP is the de facto standard. Several reasons that TCP appeared earlier, so it comes before the OSI model. OSI has a complex structure that could result in heavy processing. Okay, let's start. This is the OSI model. It has 7 layers. We will explain each one of them in detail soon. The application, let's start with the application layer. It goes from the top to the right in the center. So it has the application, the first layer, and then the presentation, the session, the transport, the network, the data link, and finally the physical layer. Here it shows you like uh, device A want to communicate with device B, and they have intermediate nodes, of course, to share data. And here it shows you like it's peer-to-peer protocol from each one to another. It will start from here and it will go to here. So first of all, it's start with the application. The data goes from the application to the presentation, then to the session, then to the transport, then to the network, and then to the data link, then to the physical layer. And then it will go to the intermediate node. Note that each device has the 7 layers, but the nodes only need 3 layers, which is the network, the data link, and the physical. So when the data comes from the physical layer of the device to the physical layer of their intermediate node, it will go from the physical of the node to the data link to the network, and then from a network it will go down to the data link again, and then to the physical layer, and it will go to the another node, and same process. It will go like this. Then it will go to the physical layer of the another device that we want to reach, that we want to deliver data to it. Then it will go to the data link, then a network layer, then transport, then session, then presentation, then application, then it will be received to device B. So router here it's a router, the node here, intermediate node is the router. Router uses 3 layers. Switch use 2 layer. If we have a switch, it will use 2 layer, and the hub will use only 1 layer, which will be physical, and the switch will use 2 layers, which will be physical and data link, and the router, in our case here, it will use 3 layers, which is the physical, data link, and the network. As we said, like the extension data. Here we have the header, and here is the data, and it will go like this, and it will through the transmission medium. It will go from here, and it will be decrypted, and so on until we it will reach to another device. So here the process here it's called encapsulation, and here it's decapsulating until to get the data. All right. Application layer. The first layer provide user interface and support to enable the user to access the network. So either you memorize the jobs of each layer, or you can like by sense try to make sense of it and understand it. So the first application layer interfaces and support to access the network. So we have like examples: electronic email, remote file access and transfer, access to www, and so on. Communication at the application layer is between two processes, two program running at this layer. So the sender have the application layer process running, and also the receiver will have his own application layer running. And as we can see, like the sender, always the arrows go from up to down, and also it's indicate encapsulation. And in the receiver side, also also always the arrows go from down to up, which mean decapsulating the data. So this for the application layer. For the presentation layer, it got three jobs. Translation, it translates between different encoding methods. Encryption for privacy, so it's encrypt the data to make sure it's private, and to not make any unauthorized access or something. Compression, which means reducing the number of bits contained in the information. Useful in video, audio, and so on. As we said, here we have a header and the data, the presentation layer. So here it will translate and encrypt and compress the data in the sending size, and the receiving size it will do the reverse of it. Uh, like for example, in encryption, it will decrypt and so on. The session layer, it has two jobs. Like dialog control allows two systems to enter into a dialog, either half or full duplex, as we explained in the previous lecture, in chapter 1, I guess. Uh, the it will here in the session layer we will decide either we want simplex or have duplex or for duplex communication, and also it will do another job which is synchronize, add checkpoints, synchronize points into a stream of data. So as you can see here, it have the synchronized between uh, each data, and also we have the header. Uh, yes, that's it, I guess. Transport layer. The transport layer is responsible for the delivery of the message from one processes to another. It's encapsulate the message into transport packets called segments or user datagram. Send the message from the program running at the host to the corresponding program running at the destination. Uh, on the sending side, messages are divided into segments having sequence numbers. So you can see like the data is divided into segments. So there's segment 1, segment 2, segment 3. On the receiving side, the packet segments are reassembled. So it will be like connected to each other again. Checked for errors. Also, it will check for error and acknowledge. Perform error hand, ensuring all data is received in the proper sequence and without errors. So we want to make sure like the sequence 1, then 2, then 3, and so on, not like sequence 3, then 1, then 2. So we want to make sure the order of sequence number is correct, so that we by that we make sure that the data is correct. Uh, Perform error, ensuring all data received in the proper sequence and without errors, of course. If there are errors, the data is retransmitted, so it will ask to retransmit the corrupted data. So here each one of them has a header also. And as we said, the arrows go from up to down, and this process called encapsulation. And in the receiver side, it will go other way around from down to up, and it will go uh, decapsulation. Uh, of course, process to process delivery. Like here, we have a process to process, which means like maybe we have more than one task we are doing currently, so we want to make sure that through the internet, which process exactly we want to like access or communicate with. So the network layer, which is host to host delivery, which is usually correspond to the concept with to IP, it will make sure that you are in the right device, like you are communicating with the right device. This will be sure by the network layer, which and its job is to identify two devices and make sure they are both connected correctly via the IP. But it cannot know like which port or which process are we communicating exactly. So the IP will only make us reach the device, but not the process that we want. And here there comes the job of the transport layer, which is process to process delivery. So we want the transport layer job is to uh, show us which process exactly. Is it this process? Is it this? Is it this? And so on via the port number, of course. And that's it. The network layer responsible for creating a connection between the source computer and the destination computer, handle the source destination delivery of packets, possibly across multiple networks, using the logical address, which is the IP address. So as we said, it will make sure that we are on the right device, we are communicating with the right device, even if there is many networks. Network layer includes the Internet Protocol, which is IP, which defines the format of the packets called datagram of the network layer. IP is also responsible for forwarding the datagram to the next router in the path. And here, the same photo explaining that we have a header, a data encapsulating and decapsulating. Here we have an example. So we want to send data from the node with network address A and the physical address 10 located on the LAN to a node with a network address B and the physical address 95 located on another network, which is this device. How are we going to send it? The IP address will make sure that we connect this device with this device. This is the IP address. Mm, no, I guess does not. The IP will make sure, of course, to it will go to the destination appropriate device that we are trying to talk with. But here it's explaining another thing. Like it's explaining that IP address alone can't reach to the other device. We need also the physical address. And because the two devices are located at different networks, we cannot use physical addresses only. The physical address only have local control. And of course, this also applied to the logical address. With only the logical address, we cannot reach to other logical address. We need also the physical address for uh, the things that are coming in the way before we are reaching to the final device. What we need here are universal addresses that can pass through the line boundaries. The network logical addresses have these characteristics. So it says that the IP can have a connect from one device to another, and the physical address from the intermediate nodes. Like here, for example, we have a trailer, we have the data, and we want to send it from A to B. And here A to B is the IP, you can say. So it already knows that we want to go from A to B. But the intermediates, it don't know. So here we need the physical address, which means here it's 10, here it's 87, here it's 20. So we want to get to the first router. So from 10 to 20, and then the data goes from this router to this router. So it will go from 99 to 33, and then from 66 to 95, the final address to reach the device that we want. So here it shows you how like the physical address and logical address work together in order to uh, get from device A to device P. Source to destination delivery. Here it's also here explaining the thing that I wanted to show, like source to destination delivery, like that I want to communicate from device A to device F or D. I can use the source to destination delivery, which is the IP, in order to know what device do I want to communicate. But the intermediate things that I can't know via only the IP. So I need hop-to-hop delivery, which is the MAC address, which is the physical address, which is the MAC address. Here it's the hop. So here it's MAC, and so on till I reach. And the IP to show me like the device that I want the end system. The IP shows you the end system, the device A and D and F, but it's alone without the physical address. It cannot communicate. So we need the physical address or the MAC address in order to know the intermediate nodes. And here it shows you via the layers concept. Data link layer. The data link layer is responsible for transmitting the datagram packets from one node to the next. Makes the physical layer appear error-free to the upper layers, network layers. Physical layer is the layer that we are going to do next. So the data link layer is like make sure that physical layer have no error. So it have four jobs: the framing, divide the stream of packets datagram from the network layer into frames, and also the physical address, flow control to prevent overwhelming the receiver, error control to make sure that no errors and detect errors, and so on. So here it have a trial also. It have a header. The header, as we know, it will contain the MAC address for the sender and receiver, and the trial for that for error detection, I guess. Example, okay. A node with a physical address 10 sends a frame to a node with a physical address 87. The two nodes are connected by a link. At the data level, the frames contains physical address in the header. The trial usually contains extra bits needed for error detection. Okay, as I said. So here we have the trial for error detection. Here we have the data, and you have the source address, the MAC address which is 10, and the destination address with the 87. So it will receive smoothly. Uh, and here it show you like do the job of divide the stream packets into datagrams. So it will do its job by adding the trail and the source and destination address. Hop-to-hop delivery. Yeah, here we don't need the physical address because we are at the data link level only. So the MAC address only is enough to reach from a device to another. The physical address, which is the last address, establish the physical characteristic of the network, type of cable, connectors, length of the cable, and so on. Defines the electrical characteristic of the signals used to transmit the data, like the signal voltage, duration of voltage, and so on. Transmits the binary data bits as electrical or optical signals, depending on the medium. So here it deals with the electricity with the bits like zeros and ones and so on. So here we have a header as a binary and also the data. It will go from transmission medium to the receiver side. Okay, a summary of the layers. You must know here the application, like it's allow access to network resources. The presentation, like we use it to translate, encrypt, and compress data. The session, here we like to establish, manage, and terminate sessions. Also here we have in the session layer, the dialog, a control to decide which dialog we want to have duplex, full duplex, and also synchronization. And transport layer, we have a process to process, message delivery, and error recovery. So here we have sequence number, as I remember, sequence numbers and segments. Also, it has acknowledge to check for errors, acknowledgement to check for errors, and the network to move packets from source to destination and to provide inter-networking, like the IP, the concept of IP. Data link to organize bits into frames, to provide hop-to-hop delivery, as we saw. Uh, physical layer to the physical layer. Also, the data link has the job to make sure that the physical layer is error-free. So it does the job of framing and also physical address, the MAC, and flow control and error control. Here, the physical deals with the medium and with the mechanical and electrical specifications. All right, now the other type is the TCP/IP protocol suite. Uh, it's less, it's like 5 layers. So the OSI model is 7 layer. The TCP/IP protocol suite is 5 layers, but it's with the same concept. I guess like there's 3 layers are combined. We will see now with the figure, but now let's read the slide. The layers in the TCP/IP protocol so do not exactly match those in the OSI model. The original TCP/IP model starts with the fourth layer. So this is the first version, we can say, application, transport, internet, and link layer. But the one that we will study and the one that's the later version, or is it the second version, it becomes 5 layers. And it changed the names of some and etc. It becomes like application, transport, network, and data link, and physical. You can see like there is no session or presentation layer. I guess it's combined with the application layer. We will see with the figure now. Yes, the application contains the application, the presentation, and the session layer, and the other things remain the same. So transport, CTP, TCP, and UDP, you can see like the application and the things that they use here. The IP of the network, of course, data link and physical. Protocols define the underlying network's host to network. And here's some of the applications: DNS, CNM, Telnet, HTTP, FTP, and so on. We will study them later in details. So the difference between the OSI and the TCP/IP is the number of layers. The TCP/IP combines, you can say, the first 3 layers that are there in the OSI and make them all as an application layer, and the rest are the same. Addressing. All right, we have logical communication between pairs of layers in this model. Any communication that involves 2 parties, they need source address and the destination address, of course. We have 4 levels of addressing in TCP/IP: the physical, the logical, the port, and the specific. The physical layer is the MAC address, as we saw. The logical layer is the IP address. The port addresses destination between several programs, like this the transport layer job, I guess, to make sure what processes we are looking for. As we said, each parties has more than one process, and the job of the transport layer is to make sure which process to choose from via the port number. So if, for example, if we have 4 processes and we want to, the port number will help us to identify to the HTTP process only, and we will select it and communicate with it. Specific address, it's like an email or a web. Addressing in TCP/IP protocol suite. Uh, Here we have the application layer, transport layer, network, data link. Okay, so here it says you like the application layer, like what type of addresses with each layer. So the application layer, it's with the specific address, as we said, the email, for example. Transport layer with the port addresses, as we said, to know what processes we are looking for via identifying or selecting a specific port number. Network layer with the IP address. So we will go, of course, with the logical address, and a data link layer and physical layer, of course, with the physical address and or the MAC address. Here we have the naming. Okay, like the frames, datagrams. Maybe you have to memorize it. So the application layer. Uh, its addresses, as we said, names, and its packet's name is message. The transport layer deals with the port numbers, as we said, and its name is segments or user datagram. Network layer deals with the logical address IP, and it's named in datagram. The name is datagram, and in OSI model it was named packets. So I don't know if we can call also this datagram and packets, or it's only for the OSI model. Uh, Data link layer, it's a link layer addresses, and it's called frame, and the physical layer the buckets names is bits. The physical address will change from hop to hop, but the logical address usually remain the same. Of course, as we said, because it's the physical address deal from different intermediate nodes, so of course it will change with this process. But the logical address it's only deal with one IP. Like I want to communicate with Faisal. Faisal has one device. This device has one IP, and IP generated from the internet that he is using. Unlike the physical address or MAC address is associated with different devices. Each device has a unique MAC address. Okay, multiplexing and demultiplexing. Multiplexing in case means that protocol at the layer can encapsulate, as we said, encapsulate a packet from several next higher level protocol one at a time. So here, when we are at the sending side, or where we have many things to do at once to make it at the lower or as a one thing, we call this as a multiplexing at the source. So always the multiplexing will be in the source side. The deep multiplexing is the reverse. It's when we have one thing and we make it to uh, distributed to many things. So it will always will be in the destination side. The multiplexing will be at the source side. The demultiplexing always will be in the destination side. Means that protocol can decapsulate a packet from several next higher layer protocol one at a time, of course. Multiplexing at the source, at the source, and the multiplexing at the destination, as we said. Of course, you can read the book for more details in chapter 2. And now we have other thing, which is client server programming. That's also part of the chapter 2, as I can see. You can read the details, of course, in the books. Maybe I will take a look at it to explain some commands, but maybe we won't need it. So let's go. Socket programming TCP using Python. So introduction, the communication at the application layer is between two running application programs called processes, a client and a server. A client is the running program that initializes the communication by sending a request. The server is another application program that waits for the request from a client. Uh, so the server is always like on and waits for requests, and the client is the one like initialize the communication. So it's not always open from his side. The API application program interface. How can a client process communicate with the server process? A computer program is normally written in a computer language with a predefined set of instructions that tells the computer what to do. If we need a process to be able to communicate with another process, we need a new set of instructions to tell the lowest four layers of TCP IP suite to uh, open the connection, send and receive data from other end, and close the connection. The set of instructions of this kind is normally referred as an application program interface (API). So he's here illustrating the concept of API. Uh, the client side, of course, we have the application layer, as we can see, the socket interface, which is the last four layers. He mentioned it here. We will how to make these four layers like communicate with each other, because the problem is with the last four, I guess. So it will be the job of IP API. So client and server has same layers, of course. Here it tells you like the keyboard, the application program will read from the keyboard, and it will write to the monitor to show you things. And when it comes to file, it will read and write to a file, and also to the socket, it will read and write to a socket, which is socket interface, the last four layers. Here we'll start like understanding some lines of code. Try to understand like as you can, like don't memorize it. Here it says from socket import star, so we import everything from a socket. Then it says the server name. It will give it the name or the name of it, which is server name. Then the server port, as we said, like to know which processes are we in. So we have to specify the server port number. And then a client socket. Here we have the socket IP, INET, uh, underlying network. So here he means by this underlying 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 network is using IPv4. Okay, and socket stream, which means it's a TCP socket. TCP socket. Uh, we will have other one for the UDP, so it will be a difference here. Uh, Here we are using the socket stream, which means that it's a TCP socket. Uh, Client socket.connect. We will provide the server name and the server port. Here we connect. So we made here the handshake. We will know more about the handshakes later. Here the sentence, the inputs, the things that you want the client will enter. So he will enter any sentence in the lower case, and then we will send it to the server, like via the send command, and we will have the sentence that we got from the client, and we will encode it, and then we will receive the modification sentence from the server. So we will have dot receive, and we will write this number 1024, and we will receive the uppercase sentence from the server. Here we will print the thing that we got from the server, and of course it will be encoded because we send it as a we will encode it via some encoding method. So the server also we will receive it from the server as encoded with the same encoding method. So we will have to decode it. After we decode it, we have now a sentence that we can read, and it will print it. Here, client socket.close, it will make the other handshake in order to close uh, the connection. So here it make a connection, the handshakes, the connecting handshakes, or establishing a connection handshakes. Here it will make the dot close, it will close the handshakes, it will close the communication via closing handshakes. What else? Now we were in the client program. Now we will be in the server program. Uh, Same thing. It will import then server number, then the socket IPv4 and socket stream, which is TCP. Here it will bind, and it did not write anything because it's the IP of the server. Here it should be the IP of the server. You don't have to write it, I guess, because you are on the server. And here the server port, which we identified as 12000. So uh, then it will listen for a response or a request. So it will listen one response at a time. What else? Then print the server is ready to receive. So it tells the client that I'm ready to receive. So while true, connection socket, other server socket to accept. So accept any request from a client. Here it will receive the connection, to receive the message from the client, and it will decode it as we said. Uh, then it will make it in an uppercase letter. Then it will send it to the client. So dot encode. So it will encode it again so that the client have to decode it as we saw, and then it will close the connection, the handshake here. TCP server program tells you like the server process here, the client. Uh, the TCP server process has two sockets. So here's the client, here's the connection socket, here's the three-way handshake, the welcoming socket. And also when terminating the socket or connection, we will have also a three-way handshake. And that's it for the client server program. Related nodes, we mean by this, the related nodes, it's like actually in the book, chapter 2, application layer. Uh, you can go through it, like you can go for each line of code and see the explanation for it, the socket model, like it will explain for you each line in details. I just gave you a simple things you can memorize or understand, but here, if you want in details, as we said here, the IP4 socket datagram means it is a UDP. We will take it later. Uh, what is the TCP? As we said, this socket diagram. Okay, I guess this notes explain the UDP and TCP. So maybe the TCP is low or down. So just if you want more details and you want to understand more, you can read each line of code and read the detailed explanation for it. And that's it for chapter 2, I guess.